Welcome to clickmyproject.com. Let us discuss the process called cost minimization and loss minimization based transmission network expansion planning with distributed generation penetration. Let us discuss the abstract for this process. Here, the system uses GBEST artificial bee colony algorithm. GABC control parameters of the best solution were found through several numbers of runs. GBEST artificial bee colony algorithm, which is a population based search procedure, is adapted to solve the TEP problem. Then it is tested on the Garver's 6 bus system and a real transmission network of the regional electric company in order to demonstrate its effectiveness for the solution of the desired TNEP problem. To validate the performance of GBEST artificial bee colony algorithm, the results obtained are compared with other optimization methods. The static TEP problem was analyzed for 3 different cases. In a natural bee swarm, there are 3 kinds of honeybees to search foods generally, which include the employed bees, the onlookers, and the scouts. Then, distributed generation is rapidly increasing its penetration level, and it is expected to play a more important role in the power industry. An important benefit of distributed generation is its ability to defer transmission investments. Here, the impact of distributed generation in the transmission network expansion planning. The objective of transmission network expansion planning is to minimize the transmission line investment cost required to meet the growing load and the added constraints. Then the advantages are GBEST artificial bee colony algorithm takes the information of global best solution to guide the search of new candidate solutions in order to improve the exploitation. It is used to improve the exploitation, which takes the information of global best solution to guide the search of candidate solutions. Finally, GBEST artificial bee colony algorithm has been applied for static TEP problem. Garver's 6 bus and IEEE 24 bus test systems are used to solve the proposed problem, and results obtained are compared with other optimization methods. Here in GABC algorithm, the position of a food source represents a possible solution to the optimization problem, and the nectar amount of food source corresponds to the quality of the associated solution. Let us discuss the flowchart for this process. Here in transmission, in order to match with the load growth and generation patterns schemes, optimal transmission network expansion planning has to be done. The objective of transmission network expansion planning is to minimize the transmission line investment cost required to meet the growing load and the added constraints. The TNEP problem is a large combinatorial problem. As many possible configurations of the network may satisfy the demand and, more importantly, might have very similar or equal cost. A common approach to tackle the problem is to use the DC model formulation for the power flow equations. Transmission network expansion planning is an important part of power system planning in both conventional and new structured power markets. Then in the buses network, the bus is the data link in a bus network. The bus can only transmit data in one direction, and if any network segment is severed, all network transmission ceases. A host on a bus network is called a station or workstation. In a bus network, every station receives all network traffic, and the traffic generated by each station has equal transmission priority. Then in generation, the power generated at generating station is in low voltage level, as low voltage power generation has some economical values. Low voltage power generation is more economical than high voltage power generation. At low voltage level, weight of insulation is less in the alternator, and this directly reduces the cost and size of alternator. Then G-best artificial bee colony algorithm. It is an algorithm in which a population based search procedure that is used as an optimization tool in solving complex non-linear and convex optimization problems. G-best artificial bee colony is a relatively new member of swarm intelligence. It tries to model natural behavior of real honeybees in food foraging. Honeybees use several mechanisms like waggle dance to optimally locate food sources and to search new ones. And the overall performance is good. Then we plot a graph for difference between number of iterations and total investment cost. Now we are going to discuss about the running procedure for this process. Here the main code is in power.m. Now I am running this file. See here, first we are initializing different types of loads. First one is constant load. Here we are calculating without distributed generation and with distributed generation. Next, industrial load. Here also we are calculating without distributed generation and with distributed generation. Then for residential load, and then for commercial load, and finally for mixed load. So we are calculating and initializing for 5 loads. Then MVA for different load models with different bus systems. MVA means megavolt ampere. Here we are calculating megavolt ampere for different bus systems. First one is 38 bus radial systems. Here PL means power load, and here PLDG means power load with distributed generation. QL means reactive power. Here QLDG means reactive power with distributed generation. Then megavolt ampere. Here megavolt ampere with distributed generation. And finally for value of MOF. MOF means mode of frequency. Then megavolt ampere for 30 bus systems. Here also we are calculating the same process like 38 bus systems. Then the location of distributed generation in 38 bus radial systems. DG means distributed generation. We are calculating distributed generation and location. Then location of distributed generation for 30 bus meshed systems. Here we are calculating the distributed generation and location. This is the analysis chart. This is the graph plotted without generation resizing and with generation resizing for difference between the number of iterations and investment cost. We get two graphs. In this, the second one with different values. We are calculating for the same process like difference between number of iterations and total investment cost. Blue color line is without generation resizing and red color line is with generation resizing. Then finally optimization chart. See, in this optimization we are calculating economic dispatch with the distributed power for without transmission loss and with transmission loss with different distributed power. Here without transmission loss with PD is equal to 900 megavolt. We are calculating each generations and the total fuel cost, finally total emission for all the process. Here with transmission losses for PD is equal to 900 megawatt. Here also we are calculating generations and total fuel cost, finally total emission. Then for PD is equal to 1170 megawatt with the transmission losses. Here the same PD is equal to 1170 megawatt for without transmission losses. So this is the final result, and it is an optimization chart.